This is part 2 of the video, Physics 102A Homework Solutions. This is number 45 on Chapter 13. We start with 18 kilograms of water and 6 kilograms of water at their various temperatures, and we want to find the final temperature. So we start with Q1 plus Q2 equals 0, and we make substitutions. Each Q is the mass times C times delta T. I can factor out C and then divide both sides of the equation by C because it's the same. And so now we're left with the mass of 1 times its change in temperature plus the mass of 2 times its change in temperature equals 0. If I'm solving for change in temperature, I want to algebraically isolate T and then get it on its own to the left-hand side. So I'll distribute my masses. Then, in an effort to isolate T, I'll get T times M1 plus M2 minus the other mass temperature combinations. And finally, after the few lines of algebra, we get that the final temperature is M1 T1 plus M2 T2 over the sum of the masses. This is what I showed you in class. Looks very much like a center of mass calculation that we did earlier in the semester, except replacing the x's with t's. We plug in the given information, and we get a final temperature of 19.25 degrees Celsius. Number 47 involves 300 grams of water at 55 degrees and a mystery mass of water, I'll call that M2 at 10 degrees. When mixed together, they have a final temperature T. Since these are both the same substance, liquid water, we can see that specific heat at some point is going to factor out. So we start, as we did the other one problem, with Q1 plus Q2 equals 0. Again, we can factor out C because it's the same. And when we solve for M2, we get M2 equals the negative of the first mass times the ratio of the changes in temperature. And this is where, as I've said many times in class, you have to be careful that change is final minus initial. So for change in T1, it's 49 degrees minus 55 degrees. For change in T2, it's 49 minus 10 degrees. So change in T1 is negative 6 degrees Celsius because the bulk of water that I've called number 1 goes down in temperature by 6 degrees. Change in T2, it goes up 39 degrees, so that's positive 39. And so we get that the second mass is 46.2 grams. Number 51 involves power, and when you hear power, you should think the relationship that power is work or energy, or in this case heat energy, divided by time, which is given as 1250 watts, or joules per second. Now we talk about the heat. We have 1 kilogram of water being raised a temperature of positive 80 Celsius degrees. So we get that the heat is 334,880 joules. Now, we involve the power equation. If we want to solve this for time, we get time is heat over power. So the heat of 334,880 joules divided by the 1250 joules per second. And we get a time of 268 seconds, which is about 4 minutes and 28 seconds. Number 53. Number 53 involves 25 grams of a mystery material and 125 grams of water at different temperatures. We combine them to get a final temperature of 22.9 degrees Celsius. So once again, we start Q1 plus Q2 equals 0, and here I'm calling 1 the mystery material and 2 the water. And algebraically, I'm going about this a little differently from how I did number 45. I'm just going to get that Q2 over to the other side, so I subtract away negative Q2. So we replace our Q's with MC delta T. You can't factor out C this time because they're different materials, and in fact C is what we're solving for. So when we solve for C1, the specific heat of the mystery material, we get that it's the negative M2 times C2 times delta T2 divided by M1 over delta T1. Plugging in those numbers, the second mass is 125 grams times the specific heat of water, 4186 joules per kilogram Celsius degrees, times change in the temperature of the water, final minus initial, divided by 25 grams and the change in temperature of the material. And notice, as I've done in class, I don't really care to convert these masses to kilograms because they're going, those, whatever the units are, they're going to divide out anyway. The 125 over 25, no matter what units that's in, is just a ratio of the masses. And in the end, we get a specific heat of 8841 joules per kilogram Celsius degrees.